My name is Pawel Wargocki. I am Associate Professor at the Technical University of Denmark. And on behalf of my two co-authors, Dr. Wenjuan Wei and Dr. Corinne Mandin from CSTB in France, I am presenting today the tools for rating and predicting the indoor environmental quality in buildings. The tools are called TAIL and predic TAIL. We start presenting the tools and how they perform. I want to say a few words about the reason why those tools were created. One of the reasons is the Energy Performance of Buildings Directive and its revision from 2018, which actually mandates that the long-term renovation strategy should ensure monitoring of the expected energy savings and wider benefits, such as those related to health, safety, and air quality. In other words, this directive is mandating that indoor environmental quality is monitored in the process of energy renovation, because those benefits that are listed here related to health, safety, and air quality are related to the changes in the indoor environmental quality parameters. The other developing of those tools was the objectives of the ALDREN project, the project with the title Alliance for Deep Renovation in Buildings. This project was sponsored by European Commission and was performed or carried out between 2017 and 2020. The overall purpose of this project was to provide incentives to increase the rate of energy retrofits, particularly energy retrofits of offices and hotels. And one of the specific objectives was actually to develop or to propose the methodology for rating the indoor environmental quality for three reasons. First reason was to guarantee that parameters that characterize indoor environmental quality are not degraded during renovation process. This is the requirement of the PPD or EPD mandate, that the process of energy renovation should not aggravate the quality of indoor environment in buildings. The second reason is that this monitoring of indoor environmental quality can be used to document any improvements of parameters that define indoor environmental quality. And lastly, monitoring of indoor environmental quality can allow estimation of those benefits of which I have mentioned, because there are relations between health and well-being of building occupants, as well as their performance, learning, and parameters that characterize indoor environmental quality. So at the outset of the process, we decided to identify whether there is a method for rating of indoor environmental quality that is already in use. We reviewed the different certification schemes, standards, guidelines, and research projects to find out whether there are any standard methodology that is used, parameters that are similarly used to rate the indoor environmental quality. From this review, we learned that there are different indicators of different components of indoor environmental quality, and some of them are similar across different schemes, some of them are different across different schemes, and altogether there is about 100 different indicators, or 90 to 100 different indicators that are used to characterize indoor environmental quality. And we also learned that there is no any standard method for characterizing indoor environmental quality that is used in different projects over and over again. Therefore, because of that, we decided to develop our own rating scheme. And we call this rating and the name of the scheme is coming from the four major components of indoor environmental quality, which is thermal environment, acoustic environment, indoor air quality, and luminous visual environment. Each of those components are classified or rated or categorized based on the four categories of quality, from category 1 to category 4, which is the lowest, category 1 is the highest. And those classification follows the classification that is proposed by the standard EN 16798 that is supporting EPBD, or Energy Performance of Building Directive. And each of them is categorized based on the quality is categorized based on these categories and given the color from green to red, where green is indicating the highest quality. And then, depending on the quality of the four components of indoor environmental quality, the overall indoor environmental quality is determined, and it is characterized by the Roman number in the middle of the scheme, and the Roman number and the color. And of course, the Roman number follow the categories of between 1 and 4, where 1 is the highest and 4 is the lowest. Of course, we would like to know the relationship between the components of indoor environmental quality and how they affect or impact the overall indoor environmental quality. Since we don't have this information, in this rating scheme, we decided that the quality of indoor environment, overall indoor environment, should be aligned with the worst quality of any of the components of characterizing indoor environmental quality. In other words, the indoor environmental quality cannot be high or higher than the lowest category of the four components. That is a very, very strict requirement, but also the requirement and the methodology that is used in other disciplines. For example, when defining the quality of ambient the pollutant or the pollution that has the worst condition is determined, which is the worst, is determining the overall quality of ambient air. The same applies, for example, for the quality of water. So I don't think that there should be any reason why we shouldn't use the same approach for characterizing IEQ before we all learn how to combine those components in order to determine the overall indoor environmental quality. And of course, then about how do we measure those different components? And we selected 12 parameters for characterizing the quality of all the four components of indoor environmental quality. And for thermal environment, we decided to use temperature. For acoustic environment, noise or acoustic pressure level. For luminous environment or visual environment, we decided illuminance and daylight factor. And for the rest, all the other parameters were used to characterize indoor air quality, and they include CO2 concentration, ventilation rate, concentration of formaldehyde, benzene, PM2.5, radon, relative humidity, and visible mode. 10 of those parameters are measured in the building, and one is actually observed as a checklist, which is visible mode, and daylight factor cannot be measured and should be simulated and is simulated. And of course, this is a crude list of parameters that can define indoor environmental quality, but we decided that we should use the parameters that can be measured, are frequently measured in other projects, and are best at the time best characterizing the quality of those parameters. For example, for indoor air quality, we need to characterize the quality of air indoors and the air that is supplied to the space. This is why we include parameters that contain this information. For example, benzene PM2.5 include this information. Other parameters such as ventilation rate and CO2 are basically used to characterize the dilution and are often used as the proxies for indoor air quality. So in case of the tail, the idea is that the parameters should be measured before the renovation or after renovation, and in this way we can observe and monitor whether there are any changes to some of those parameters. And this is here the example where the change of some of the parameters actually improve the overall quality of indoor environment in a building. So TAIL is the performance metric in a sense because it actually provides information on indoor environmental quality for the building under use. For the TAIL, we also developed the protocol that should be used to monitor indoor environmental quality. This protocol is listed here and includes how many measurements should be made and during which periods, which type of measurements, with what type of instrumentation, what quality of instrumentation, and also we defined the range of parameters that define different categories. All this information can be found in the publication that describe TAIL. However, we realized that during the process of construction of a building and also renovation of the buildings, there is one important part measured the performance of buildings using a TAIL in different office and hotels buildings, and this is just an example of the parameters that were measured according to which methodology. And we determined that buildings perform differently depending on the with respect to the TAIL parameters. However, the overall indoor environmental quality could be identical because it is decided by the worst performing component of indoor environmental quality. To the test, the predict TAIL tool. Well, this tool is once again allowing a prediction using modeling and only modeling of the parameters before the building is even renovated to select the best scenario for renovation. And in order to test this tool, we defined four scenarios. Two scenarios that in which the building is renovated to achieve the best energy performance, or moderate and best energy performance, and two scenarios in which building is renovated to achieve the best indoor environmental quality and moderate indoor environmental quality. Why we did it? The major reason for that was that we wanted to basically find out whether the predict TAIL tool will be sensitive to detect changes. So here in these scenarios, we selected realistic scenarios, but we made sure that there is a difference between those scenarios and that there could be expected a difference between these scenarios. We wanted to see whether the predict TAIL will be sensitive enough to detect those differences. And as I said, we used the different simulation tools to predict components of indoor environmental quality. For thermal environment, we use trances. For indoor air quality, we use MATIS. For acoustic environment, we used Acrobat software. and for luminous we used funny. And the idea is that in the future we will be able to use any simulation tool to make this prediction. And prediction was done for the entire year. Whereas in case of measurements of tail, the proposal is that the measurement should be at least done in the worst season, best in the heating and cooling season, and the optimal would be to measure in 4 different seasons, including also spring and fall. And this is the example of those results of those different studies, which basically show that the tool is actually sensitive. So going from the base case scenario to case 1, in case of the energy scenario or renovation scenario, and going to which is the best performing scenario for both office and hotel, for which the measurements were done before, for tail, we see that there are changes in parameters. So the tool seems to be selective, sufficiently selective to allow the designer to select the best or the optimum scenario for which they would like to, with which they would like to continue in the process of renovation. Well, if you want to read more about the tail and predict tail, there have been several publications, and there are 2 publications in Energy and Building, and which are summarized in the Riva journal. This is issue 2 of 2022 this year, on tail and predict tail, the tools for rating and predicting the indoor environmental quality in buildings, and it can be actually downloaded for free from Riva web pages or Riva journal web pages. Concluding, we developed the tail and predict tail. Tail is a rating scheme allowing measurements of indoor environment or rating of indoor environmental quality in buildings under actual use. So it is a performance metric, and predict tail allows the prediction of indoor environmental quality during the process of designing the renovation of a building. We expect that they will all both become a standard method for benchmarking indoor environmental quality in buildings. Such benchmarking does not exist, although there are different certification schemes that use such benchmarking, but they use different types of benchmarking and different methods, often not based on the measurements, but basically on qualification of certain elements that exist, providing the credit method. And it's also expected that the use of both of the tools, so rating scheme and the prediction tool, will lead to the general improvement of indoor environmental quality and the entire process of renovation of buildings that is now taking place. Thank you very much for your attention.
This is everything from my side. Thank you for your attention, and feel free to follow up on the user project through the different means online.